Hey folks, I guess we are live. Let me just check if everything is all right and then we'll get going. So just give me a sec. Uh, we'll get going. Okay, yeah, everything seems to be good. No issues whatsoever. So yeah, let's wait for a few more minutes for everyone to join in. I'll also keep an eye on the chat section once most of the students join in. Let me make a couple of announcements. Uh, So Deepak says, what are the subjects shall you be teaching in GATE? I mean, we are covering almost all the subjects that are there in GATE, right? And I personally, I'm the default teacher, but we have instructors for other subjects. And we have a DLD and CO that is being done by a very experienced professor who has been teaching GATE for 15, 20 years. Aptitude is something that we have a very experienced faculty member who has been teaching aptitude for over a decade. We're also trying to get other faculty members for other subjects with a lot of experience teaching it. So if you don't find anybody, I am the default teacher. But if you find somebody who has a lot of experience, we'll certainly get that. So somebody says getting demotivated by seeing previous GATE score. That happens to everyone, right? So, I mean, see, at the end of the day, GATE is a non-trivial struggle. It's also a long-term investment of time, resources, and energy. So it's very, very valid that people do get discouraged because of their score in the previous exam or so. That's very understandable, to be honest. But what is the way out? Right? The only way out that I know of is to put in the effort, stay motivated, keep the end goal in mind. Okay, persist with your efforts, and just do your best. Right? That's all we can do. If you get demotivated and move away from the course of preparing for GATE, it will hurt you dramatically. Right? So all I can suggest you is it's okay. It happens to everyone. It's a very common thing. Personally, when I was preparing for GATE in my third year BTech, again, in those days, GATE was valid for 2 years. I could take the test in third year and join after fourth year. I prepared very, very hard in my third year. I actually prepared with an intention of getting a single digit rank, but I messed up in the exam. I literally messed up in the exam. I panicked because it was one of the hardest papers in GATE in the year 2006. I messed it up. I got a decent rank, but not the rank that I was preparing for. So next year I said, okay, I learned from my mistakes. I put in the right amount of effort with the right focus, and I got a good rank. Right. So that's what life is all about. We have to learn lessons from where we have messed up, keep moving and keep working hard. There is no escape from that fact. Right. So somebody's asking about calculus and probability. I'll just come to that. I'm just waiting for a couple of minutes. Let everyone join in. I'll talk about calculus and probability. And yeah, so just wait for a minute. Hey, Akhtar. Yeah. So Akhtar, to be honest with you, as you said, you're demotivated. See, the only way to keep yourself motivated is to look at what lies ahead. Okay. See, look, very simply speaking, of course, everybody is motivated by something different. You might be motivated by a better career, a better job, a or a more well-paying job, or you're motivated by intellectual curiosity, right? Whatever motivates you, just understand that GATE is a means to that end, right? Just don't forget that simpleton fact, right? That if you give up on GATE, your aspiration of working on great projects or great research work or your intellectual satisfaction or a good job, all of them will go down the drain. So the best way to keep yourself motivated in the long run, right? In general, again, this happens to me, right? When I create some of these subject notes, I get demotivated. It happens to all of us. The way I tackle with it is I keep a long-term view of things. Okay, I just say, okay, this is something that I'm passionate about. This is something that I think that I see purpose in. This is aligned with my long-term goals. So let me put in the effort. I'll put in as much effort as humanly possible within my own circumstances and leave the rest. Right? So that's the only strategy forward. And the best way to motivate yourself constantly is to think about the long-term picture. Look at where you will be 5 years from now if you again prepare for GATE well versus not preparing for GATE. Look at your own seniors, your brothers, your family members who have been, or other people who have been successful the GATE route and who have not taken the gate route, got demotivated and gave up. Okay, I mean, real world data is the best motivator. Nothing beats that, right? So Deepak, actually, to be honest with you, I don't think I'm the best teacher for all subjects. And again, each teacher has their own teaching style. Okay, so that's why we are trying to get teachers from a wide spectrum of backgrounds, and we are also trying to get teachers who have taught for GATE, right? Again, this is not the end and all. Will move with it, but I don't want to be a single man army, and we don't want that. We want to encourage, or forget about encouraging. We want to have a wide pool of teachers, right? And as you know, we have a wide spectrum. We have a phenomenal team. So most of the notes that most of the content that you see me delivering, it's not just one man's effort. Please understand that there is a huge army of a team that works everything from the plan of the content, what should we cover, the practice problems, the solutions, what examples we should give, right? So please don't think it is one man's job. I'm just delivering it for you. Okay, there is a huge team effort behind it, right? So please understand that. uh, So, Akhtar, that's okay. See, Akhtar, it's perfectly valid. People do fail in their attempts. That's the part of life. Okay. Failure is something that we all have to learn to deal with and move on. Okay. We will try and do everything from our side. If you put in full effort, we'll try to do everything from our side to help you in every way possible. Okay. Just stay motivated and let's crack it. Right. So, since we are anyway 8 minutes into this, I wanted to make a couple of announcements. So today, as we discussed in the last live session, today we'll whatever is covered in aptitude, we'll stop it here, because most of the exams for most of the students are done, both for third year students and final year students at most universities. We want to speed up now. Okay, it's very, very important that we speed up now. Okay, so I ask all of you to cooperate with us. We'll be giving you more content than normal. So we've also shared the schedule for calculus. The next topic we'll cover, because we finished linear algebra earlier. Now let's start calculus, right? So we'll try and finish we'll start calculus from tomorrow and we'll finish it by Sunday. Unfortunately, this Sunday we'll give you content. Okay, because we want to speed up, guys. Okay, we want to have all the subjects done for the first batch by mid to late August. By second batch, maybe a couple of weeks or 3 weeks later that. So for every batch, we want the content to be done as soon as possible. Since all of the exams, again, by the way, we slowed down a little because some of you had exams for the last 15 days or so, right? Now, no more excuses. Let's dive in. Let's go full speed, right? So my first suggestion to all of you is, we'll try and put out content the night before or early in the morning, right? Every day. So I think we've already shared the schedule, right? For calculus, it will be 4 days of schedule, 16th, 17th, 18th, and 19th. I understand that 19th is a Sunday, but let's finish it. In 4 days, we can finish calculus. Okay, and calculus is something that we have been doing from our 11th and 12th class. So some of the basics of calculus, like L'Hopital's rule, right? Some basic differentiation, finding maxima, minima. These are stuff that we learned in our 11th and 12th grade. Of course, I'll revise everything from scratch. Okay, I'll cover everything from scratch, but this is something that we can cover fast, right? Because this is something that we've been studying. Of course, some of you may have forgotten some of these basics, but we'll revise everything and let's do it fast. So instead of a Saturday live session, let's do a Sunday evening live session. Because in these 4 days, we'll finish all of calculus. We will send you the subject test for calculus on Sunday morning, right? Sunday morning, you'll have the subject test. Instead of Saturday evening live, let's do Sunday evening live and finish off calculus in these 4 days. 4 days, one subject test, let's finish. Once calculus is over, then we'll go into discrete mathematics. Also, not exactly discrete mathematics, we'll go into sets, relations, functions, lattices, lattices and group theory, or algebraic structures as it is called. We'll finish that chunk and then we'll keep moving on. So let's finish all of discrete mathematics and engineering mathematics in one big go. So all I ask of you is, please, let's put in more effort. I know some of you are working professionals, but the faster we can finish the content, the more time we'll have for practice. And practice is as important as knowing the theory. Okay, so this week, unfortunately, we're not giving you Sunday break because we've given you enough break for the last 15 days with aptitude content, right? So I think many of you have taken some break because it's easy to cover. So now, no more excuses. Let's dive in. Let's move fast. Okay, sounds good. Let's dive in here. 1 second. Okay, so let me go into the practice problems. Okay. Okay, I hope all of you can see the screen here. And okay, so we have the 15 practice problems here. Just give me a second and let's dive in. By the way, except for a few problems here, most of them are easy. Okay, we can actually solve them fairly quickly. So the first question says a boat takes 26 hours for traveling downstream from point A to point B and coming back to point C, which is midway. So this is point A, this is point B, and this is point C. Point C is midway between A and B. So it takes 26 hours to go from A to B and back to C, right? If the velocity of the stream is 4 kilometers per hour, right? And the speed of the boat is in still water is 10 kilometers per hour, what is the distance between A and B? Very simple question. Again, for many of these questions, as I've told you earlier in the previous live sessions also, and one of the easiest ways to solve problems like this is to use variables, right? So now let's see the downspeed velocity or downspeed. So what is the downspeed velocity now? The speed of the water in still water, the boat is at 10 kilometers per hour and the stream itself is going at 4 kilometers per hour. Let's assume this is the downstream direction, right? So what is the downspeed velocity? It is 10 plus 4, right? It is 10 plus 4, which is 14, right? What is the upstream velocity, right? So, sorry, it's not downspeed, it's downstream, sorry. Okay, so what is the upstream velocity? Upstream velocity is 10 minus 4, which is 6. Simple relative velocity stuff, 6 kilometers per hour, right? Now let's assume that the distance between A to B, let's assume this distance is D, right? Then what will this distance be? This distance will be D by 2, right? Because it says C is midway between A to B, right? And the total time it says is 26 hours, right? So I can simply say that if I travel this distance D at 14 kilometers per hour, and if I cover this distance D by 2, right? This distance D by 2, I'm covering in 6 kilometers per hour, right? So this is equal to, and so when I do this distance by velocity, it gives me time. So this total time is already given to me, which is 26. Look at this. I've used 10, I have used 4. I've also used the fact that C is midway, and I'm creating this variable D to make everything work. So most aptitude questions, if you correctly create variables to solve problems, these are simple algebraic problems, right? So this is equal to 26, right? Very simple. So if you simplify this, this will be 13D by 84 equals to 26, or in other words, D equals to 168 kilometers, right? Again, this is a simple algebraic simplification, right? If you simplify this, there is only one variable D, you solve it for D and you get D equals to 168 kilometers. Very simple question, okay? You just have to know the simple downstream, upstream velocities, and you have to know to use this variable D. That's all there is, okay? So let's go to question 2 now. The question 2 says two trains, right? Two trains of equal length running in opposite direction pass a pole in 18 and 12 seconds. The trains will cross each other in how many seconds? Right? That's a question. Very simple question again. Let's assume, because both these trains are of equal length, let's assume the length of each of these trains is x meters, okay? Any units, let's assume it's x meters, right? And we know that each of these trains cross the pole in 18 seconds and 12 seconds. And they're going in opposite directions, right? Right? They're going in opposite directions, which means what is the velocity of train 1 and what is the velocity of train 2? Velocity of train 1, which is crossing a pole in 18 seconds, right? Because its length is x, its velocity is x by 18, or its speed is x by 18, right? Similarly, the speed of this is x by 12, right? Right? Very simple. Now, how much time does it take for both these trains to cross each other? Right? So for both these trains to cross each other, imagine this is one train and this is another train. Okay, from the time they pass each other, right? From the time they pass each other. So let's assume this train is going this direction and this train is going this direction. By the time they pass each other, right? By the time they pass each other, right? This train will go this way and this train will go this way. So what is the total length? What is the total distance traveled? Right? By the time they both pass each other, they would have crossed 2x distance because the length of each train is 2x, right? So now the question here is, how much time would it take for them to cross each other? What is the distance they have to cross each other? Okay, the distance will be 2x. And we know their speeds, right? The speed of the first one is 18 and the speed of the second one is 12. And since they both are moving in opposite directions, their relative velocity or the relative speed would be added. So this is the distance and this is the relative velocity, right? So what is, if again, this is very simple, right? I can simplify this. X and X would cancel out here, right? So if I just simplify this, I can write this as, again, you can just simplify it. This X's would get cancelled here. This will be 72 by 5. 72 by 5 is going to be 14.4 seconds. Again, I'm skipping the simple algebraic stuff in the interest of time. Once you get an equation like this is trivial to solve, right? You cancel these two x's and then you simplify this, you'll get 72 by 5. Okay, that's all there is. So the answer here is B. Very simple question, straightforward, right? Again, some of these questions are at gate level, to be honest with you. So don't worry about it. So now let's check out this problem, right? So a train can travel 50% faster than a car, okay? Both start from point A at the same time and reach point B 75 kilometers away from A. So this is point A and this is point B. Their distance is 75 kilometers. The distance is 75 kilometers. On the way, however, the train lost 12.5 minutes while stopping at the stations. What is the speed of the car? Good question, right? So let's assume the speed of the car is X, right? Let's assume this is the speed of the car, right? Now, what will be the speed of the train? Because it clearly says the train travels 50% faster than the car. So speed of the train is 1.5x. Straightforward, right? Now what does it say? See, they both are traveling the same distance of 75 kilometers, right? They both are traveling the same distance, but the time they take is also the same, right? Except that the train spends 12.5 minutes stopping at various stations. Now, how can I incorporate all of this information into an equation? Can I write it this way? 75 by x. What is this? This is the time taken by the car, right? Time taken by the car is equal to, or in other words, okay, time taken by the car minus time taken by the train, right? What is the time taken by the train? 75 by 1.5x. Since they both started at the same time and reached point B at the same time, this difference has to be the time that the train stopped, which is 12.5 minutes, right? So this is equal to 12.5 minutes, right? So this is equal to 12.5 minutes, or if I want to write it in hours, right? Let's assume I want to write this in hours, because if you look at this, everything is in kilometers per hour here. This 75 is in kilometers. Instead of writing it in minutes, let's write it in hours, right? What is it in hours? 12.5 by 60. Now, if you notice, you have an equation with only one variable, which is x. You can simply solve for this, right? This is simple algebraic solving. An equation, again, the challenge here was taking a variable for the velocity or the speed of the car, computing the velocity of the train, using all the information given to write this equation. When you write this equation, it's straightforward from there on. When you simplify this, you'll get x equals to 120, right? See, the challenge in many of the aptitude problems is typically coming up using variables smartly, writing an equation like this, which is solvable. Preferably equations where you have only single variable so that it's easy to solve. So the answer here is 120 kmph. Again, the reason I converted this to minutes is because, the reason I converted this to hours is because all the numbers are in kilometers per hour. It makes logical sense. Very simple question again. Okay. So let's go to the next question here. Okay, so this is the next question. Actually, some of these series questions, I'm not very good at them. So it took me some time to figure out the solution for this. Okay, but of course, there are many strategies to solve these problems, right? So what is the difference between these two? So 82 and 107, right? So what is the difference between both of them? The difference is 25, right? The next is 207. The difference here is 100, right? What is the next? 207 and 432, right? So this difference is 225. So the moment I see these three numbers, one thing that rings to me is all of them are multiples of 25. The moment I see this, right? Similarly, the next one is 832. What is this difference? This difference is 400, right? All of them are divisible by 25. This is nothing but 25 into 1, right? So this is 25 into 4, right? This is 25 into 9, right? This is 25 into 16. Now here comes an interesting pattern. If you notice, this is 1 square, this is 2 square, this is 3 square, this is 4 square. So for the next term out here, right? For the next term out here, whatever is this x, this will be 25 into 25. 1 square, 2 square, 3 square, 4 square, 5 square, right? So this is 625, right? So 832 plus 625 will be 1457, right? So 1457, which is option C, right? Again, this, I mean, it took me some time to figure this out, to be honest with you, okay? But it is solvable. Once you solve the problem, everything looks trivial, to be honest with you. Okay, sounds good. So let's go to the fifth question. So the fifth question says, a cistern has a leak which would empty it in 8 hours, right? A tap is turned on which admits 6 liters a minute, okay, into the cistern, and it is now emptied in 12 hours. How many liters does the cistern hold? Okay, valid question, right? So here, one way to simplify it is, instead of taking the cistern capacity as X, right? What if I take, because I don't know the rate at which it is leaking. Okay, what if I take the rate of leakage? Okay, so what if I take the rate of leakage as X? If I take the rate of leakage as X, what is the capacity? Because we know that when there is no tap, if the rate of leakage is X, the cistern or the tub, right, empties in 8 hours. So what is its capacity now? Its capacity is going to be 8x, right? Okay, this is these many liters per hour. Okay, if you want the metric units of it, this is liters per hour, so this will be liters, right? So now when I open the tap, right, when I open the tap, there is an additional inflow of 6 liters per minute, right? There is an inflow of 6 liters per minute, right? Which means how many liters per hour? 6 liters per minute is 360 liters per hour, right? This is 360 liters per hour. And it says it will empty in 12 hours. So in 12 hours, how many liters of water comes from the tap? In 12 hours, how many liters of water will come through the tap? 360 liters per hour. So 360 into 12, right? Which is 4,320 liters would come in through the tap, right? Right? Very simple. Now comes the thing. So now what do we have? Okay, so this will be emptied in 12 hours, right? So this whole thing will be emptied in 12 hours. And we agreed that the leakage is happening at X liters per hour. If it is emptied in 12 hours, right? See, with the tap on, we are emptying it in 12 hours, right? So which means, can I write this equation? This is the input. This is the inflow, right? This is the inflow that I have, right? 1 second. This is the inflow that I have. Just a second. Yeah, this is the inflow that I have. My capacity is 4,320. Okay. So would this equation work out? If you notice in this equation, look at this equation, right? This is the amount of water that is coming in through the tap, right? Right? This is the time it took to leak, right? Which means this amount of water was there initially, right? This is the amount of water which was there in the cistern to start with, right? This is what it would take to leak out with the tap on. So with the tap on, it says it will leak everything in 12 hours. So I can write this equation, right? Because this is my rate of leakage. My rate of leakage hasn't changed. Only the input from the tap has changed. So if you solve this equation, again, this is very simple to solve. right? So now if you solve this equation, what does it say? How many liters does the cistern hold? Right? The capacity of the cistern itself is 8x. So what will 8x be? From this equation, I can write 4x equals to 4320. So what will 8x be equal to? 8x will be equal to 8640, which is option C. Right? Slightly careful, but as soon as you get the equation, this is a straightforward problem. Right? So now let's go to the next problem here. Okay, these questions I'm slightly bad at these sequence type questions, but let's try to solve it. From the following number series given, one particular number is wrong. Okay, these are harder problems. Okay, one particular number is wrong. What is that number? Okay, one of them is wrong. Okay, so let's figure it out, right? So I have 49 and then I have 50. 49 plus 1 is 50, right? Okay, what is the next number? 46. What is 46? This minus 4. Okay, so this also seems like 1 square, 2 square, but let's see. Then I have 55. What is 55? Plus 9. Wow, now everything seems to work. This is plus 1 square, right? Then I have negative 2 square. I have positive 3 square. The next one is 38. What is 38? So what is this difference? So what should it be? See, if this is my pattern, by looking at these first three numbers, I've come up with a pattern, right? 1 square, minus 2 square, plus 3 square. So this should have been minus 16. If I do minus 16, this number should be 39, right? But this is 38. Okay, maybe my pattern is wrong, right? That's also possible. Maybe I'm just hallucinating this pattern. This pattern may be wrong. Let's see the other two numbers, right? We have 64 and 28 also. Let's see if 64 and 28 fit in this pattern, right? So what is the difference between these two? These two difference is plus 25. The difference between these two is minus 36. Yes. So 38 was the wrong number. Instead of 38, if 39 was present, my pattern is correct. So it's not that my initial pattern that I discovered using these three numbers is incorrect. Okay, it is that this 38 number here is incorrect, because all the other numbers are fitting into this nice pattern where I have positive, negative, positive, negative, positive, negative with 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, right? So again, this is possible because I could find the pattern using just the first three numbers. These are tricky problems, but the right answer here is 38. But you have to be careful when you solve problems like this. These problems can get tricky, to be honest. Okay, so let's go to the seventh problem now. Okay, so what does this problem say? This problem says a motorboat can travel at 5 kilometers per hour in still water. Okay, very good. It traveled 90 kilometers downstream in a river and returned. Okay, so it traveled some distance. It traveled 90 kilometers. Okay, it traveled 90 kilometers downstream and returned back, taking altogether 100 hours. The motorboat speed is 5. What is the rate of flow of the river? Right? So let's assume the rate of flow of the river is y. Right? Let's assume the river is flowing at some y kilometers per hour. Okay. So then look at this. What would be my downstream speed? My downstream speed is 5 plus y, because my motorboat can travel at 5 kilometers per hour, and my upstream velocity will be 5 minus y. Right? And I know the distance here, and I know the total time it took. So can I write an equation now? I traveled 90 kilometers at 5 plus y speed downstream, and I traveled other 90 kilometers upstream at 5 minus y. Right? And the total time I took, this is the time it took to go down, this is the time it took to come back. The total time it took is 100 hours. Right? Simple equation. You can solve this equation, right? This is an equation in only one variable. If you solve this equation, you will get y equals to 4. Right? You'll get y equals to 4. Again, you could also replace these values here and try it out instead of solving the whole thing, right? If y equals to 4, this will become 1, so this will become 90. If y equals to 4, this will become 10. 10 plus 90 is 100. Right? So that's another shortcut way. Instead of doing all the algebra, you can do it faster. Okay, simple question, very simple question about time and distance, right? Again, there are some tricky questions in this section also. We'll go to them slowly. So a machine can print 1 lakh books in 8 hours. Machine Q can print same number of books in 10 hours, while machine R can print them in 12 hours. All the machines started at 9 a.m. while machine P closed at 11 a.m. and the remaining two machines completed the work. Approximately at what time will the work be finished, which is to print the whole 1 lakh books? Okay, again, these are very standard problems where multiple people are trying to achieve a piece of work, right? So let's look at, so for problems like this, you should always look at how much 1 hour work gets done. Okay, so this is important. If you take P plus Q plus R, all three machines, let's assume, are working. Okay, in 1 hour, how much work would they get done? Look at this. So it can print the whole, it can print all of the 1 lakh books in 8 hours, which means in 1 hour, it will get 1/8 of the work. P can get 1/8 of the work. Q can get 1/10 of the work done, and R can get 1/12 of the work done. So if all these three machines are operating parallelly, simultaneously, right? So the total work that will be done is 1/8 plus 1/10 plus 1/12, right? If you simplify this will be 37 by 120, right? Very good. So now we started at, all the machines started at 9 a.m. and machine P closed at 11 a.m., right? So which means all these three machines worked for 2 hours, right? All these three machines worked for 2 hours, which means how much work have they gotten done? 37 by 120 into 2, which will be 37 by 60 work got done by 11 a.m., right? By 11 a.m. in 2 hours time, 37 by 60 part of the work is done. So how much work is still left? How much work still is left? 23 by 60 work is still left, right? And this work got done only by Q and R. So if Q and R only work together, in 1 hour, how much work would they get done? In 1 hour, they would get 1/10 plus 1/12 amount of work, right? If you simplify this will be 11 by 60. So they can finish 11 by 60 work in 1 hour, and they're still left with 23 by 60 work, right? So how much time would they take to finish this whole work? If you look at this, 23 is roughly slightly more than 2 hours, right? So only these two people are left. After 11 a.m., nobody is left. After 11 a.m., nobody is left. Only Q and R are left because P has already stopped working, right? So if you notice these two numbers, this is the amount of work that is left, and this is the amount of work that would get done by Q and R in 1 hour, which means this is approximately 2 hours. Slightly more than 2 hours would be taken, right? So which means after 11 o'clock, I'll still work up to 1 p.m., slightly after 1 p.m. So the closest answer here is 1 p.m., right? Up to 1 p.m., Q and R have to work to print all the books, right? Again, simple question. You just have to be careful to make everything in terms of 1 hour works. Whenever you have this work type questions, okay, convert everything to 1 hour. This is how I used to solve problems even when I was younger, right? So whenever you have this time work type of problems, convert everything to 1 hour work, you can trivially solve them. Okay, so let's go to the 9th question now. Okay, again, I'm bad at these questions, but let's try. Okay, this is a tricky one. I really struggled with this question, to be honest, guys. Okay, I really struggled with this. So, okay, so what is the missing number here? I tried to subtract, I couldn't find any pattern. Okay, again, I had to take help from my team to figure it out, to be honest with you. Okay, it seems I have to reverse these numbers. Okay, so 289, 256, okay, 225, okay, some reverse of question mark. Okay, this is 169. It seems you have to reverse these numbers. The moment they gave me this hint that I have to reverse these numbers, I got the pattern here, right? This is 17 square, right? This is 16 square, right? This is 15 square, right? So this has to be 14 square. And what is 14 square, right? If you take 14 square is basically 196, right? And this is 13 square, right? So 196, I have to reverse. If I reverse 196, you get 691, right? So the answer is this. To be honest with you, when I tried to solve this problem, I struggled, and the team helped me, said, read the numbers in reverse. Okay, so this was a tricky one that I personally couldn't solve, even though I spent 3-4 minutes on this. Okay, so just telling you upfront. Okay, sounds good. So let's go to the next question. Okay, so here is a question where it says, Hari and Giri can do a piece of work in 70 and 60 hours respectively. Very good. Okay, they began the work together, but Hari leaves after some days. Okay, we don't know how many days. And Giri finished the remaining work in 47 days. After how many days did Hari leave? Good question. Okay, so let's see this question, right? So Hari and Giri can do this piece of work. They began the work together. Okay, that is good. Okay, so Giri finished the remaining work in 47 days. Okay. Okay, so if you look at this, because Giri can do 1/60th of the work. See, Giri can do 1/60th of the work in a day, and Hari can do 1/70th of the work in a day, right? Because it says 70 and 60 here. So Giri finished the remaining work in 47 days, right? Which means Giri actually finished 47/60 work in those 47 days, right? That's the amount of work that he has finished, right? So how much work was done together? If you notice how much work was done together, right? So 13/60 work, 13/60 work was done. So this was done by Giri. I'll write it as G. Okay, this was the work done by both Hari and Giri together, right? This is important, right? Now, if Hari and Giri work together, how much work can they do in a day? Per day, Hari and Giri together, how much work they can do? 1/60 plus 1/70, right? So this is the amount of work that they can do per day. Now the question here is, this is the amount of work that they have done together. This is the amount of work that they can do in a single day, right? Very simple. So how many days would they take to finish 13/60 work? Very simple. You can actually make that whole thing work. Okay. So if you notice, what is this, right? So if you do 1/60 plus 1/70, this will be 420 plus 70 plus 60. So this will be 130/420, right? So this will be 130 by 427. Sorry, 13 by. Sorry, this is 13/420. I'm sorry. So this is 13/420 work they can do in a day. Okay, and they did and they have to do 13/60 work. Simple. They'll take 7. So they both worked for 7 days, right? So if they can do 13/420 work per day, right? If they work for 7 days, they'll do 13/60 because 6 sevens are 42, right? So Hari actually left after 7 days. That's the answer here. Simple work-based questions. Okay. So let's go to question 11 now. Okay, so this says Mary and Kate. Okay, these clockwise, counterclockwise are also slightly tricky. We have to be careful. Okay, so Mary and Kate are running clockwise around a circular track with a circumference of 500 meters. Okay, so this is a circular track. Its circumference is 500 meters. So this length is 500 meters, each at their own constant speed. Okay, so Mary runs 1,000 meters every 5 minutes. Okay, what does that mean? So it means Mary runs 200 meters per minute, right? That's what it means, right? So Mary runs 1,000 meters every 5 minutes. Yes, 200 meters per minute. Kate runs 1,000 meters every 6 minutes, right? So what is Kate's speed? So Kate would run at 1,000/6, which is 500/3 meters per minute, right? This is Kate's speed, right? Very good. Now, if Mary and Kate start opposite one another on the circular track, so if Mary is here and Kate is here, okay, they're on opposite ends of the circular track, which means what is the distance? The distance. So this distance is 250 meters, right? They're on the opposite ends. So this distance between both of them is 250 meters. Okay, how many minutes? 1 second. Are they running? Okay, both of them are running clockwise. Okay, so both of them are running in the same direction. So the question here is, how many minutes must Mary run in order to pass Kate and again catch her? Okay, which means, look at this. Mary, how many minutes must Mary run in order to, first she has to pass Kate. First she has to overtake Kate first and then catch up with her again. So look at this. What is the distance between them? Okay, by the way, whenever you have this overtaking type of concepts, right? How fast will they overtake? It's easier to look at everything in terms of relative velocity, right? This is something that we all learned in 11th and 12th class physics. It's actually common sense. But anyway, we learned it in physics, right? So if you look at it, look at the relative speed. Okay, if you look at it from the perspective of Kate, what is the speed, right? Because Mary is running faster. See, this is less than 200, right? Mary is running faster, right? So what is the speed of Mary if you look at it from the frame of reference of Kate? Or from K's perspective, let me not use the physics terminology. From the viewpoint of Kate, at what speed is Mary running at her? Right? It is nothing but 200 minus 500 by 3. So the relative velocity or the relative speed, I shouldn't say velocity, I should say speed here, because velocity has a specific meaning in physics, right? And here it's a circular track. Okay, anyway, I don't want to go into physics now. So the relative speed here is 100 by 3 minutes per minute. Okay, so this minus this. Now look at this. Mary first has to overtake Kate, which means she has to cover this 250-meter gap, right? She has to first cover this 250-meter gap, and then she has to again overtake. Look at this. How many minutes must Mary run in order to pass Kate and catch her again? So if you look at it from Kate's perspective, Mary is traveling at 100 by 3 minutes per minute. Sorry, meters per minute, I'm sorry. And Mary has to cover this 250-minute gap because both of them are running in the same direction. Okay, it says clockwise. Whatever direction it is, both of them are running in the same direction. That's what matters. So the total distance that Mary has to run is she has to fill this gap first and then again run 500 meters to catch up. So the total distance that she has to cover is 750 meters. If she has to cover 750 meters, right, and if the relative velocity is 100 by 3, how much time does it take? Right, very simple. It's 750 by 100 by 3. This is rough. This is equal to 22.5. So 22.5 is the answer here. Okay, so the trick here, again, this is one place where a lot of people make a mistake. Okay, so the question is very clear. How many minutes must Mary run in order to pass Kate? First pass her, and then catch up with her again. I think I'm running counterclockwise here, right? Clockwise is this, but that's okay. As long as both are running in the same direction, it doesn't matter. Okay, actually, from my own experience of running long distance long ago, all wrong distances run like this. So I was thinking to run like this. Anyway, it's okay. Okay, yeah. I don't remember running clockwise. I always remember running counterclockwise when I used to run long distance. Anyway, again, this is many years ago. Okay, so now let's look at this question. Okay, so Tammy climbed a mountain in 2 days. Okay, she spent a total of 14 hours climbing the mountain. On the second day, she walked at an average speed that was half a kilometer per hour faster on the second day, but 2 hours less than what she walked on the first day. Okay, if the total distance she climbed during the 2 days is 52 kilometers, how many kilometers per hour did Tammy walk on the second day? Okay, very simple. Okay, so look at this. She spent total of 14 hours climbing the mountain. Okay, this is the total time she spent. Okay, now let's assume on first day. Okay, let's assume the time traveled on first day is, let's say, X hours. Okay, on second day, let's assume the time traveled. Now we don't have to assume because it says that she walked 2 hours less, right? So it's going to be X minus 2. Okay, very good. So the total time is 14. So X plus X minus 2 equals to 14. We're given, right? The total time spent is 14. So what would X be? X would be equal to 8. Okay, so she actually climbed up for 8 hours on first day. Second day, she climbed up for 6 hours. So we got these 2 pieces of information. Now let's look at the speed. Okay, let's assume on first day, she went at speed S. On second day, we are told that she moved at half a kilometer more. So she moved at S plus 0.5, right? So this is what she has covered. And the total distance she has covered is 52 kilometers. Speed into distance. So S into 8, which is 8S, plus 6 into S plus 0.5. This is the total distance she has covered, right? I have the speed, I have the duration, which means I can compute the distance. This distance is 52 kilometers. And I have only one variable S. So what will S be? So S will be equal to 3.5. You can actually solve this. This is a simple equation in one variable. What is the question now? How many kilometers per hour did she walk on the second day? This is the first day. Second day, she walked at half a kilometer faster than this. So on second day, so this is 3.5. So on the second day, she walked half a kilometer faster, which means 4 kilometers per hour. So the answer here is C. Again, I just used variables and simple algebra. Nothing very fancy here. Okay. So now let's go to the 13th question here. Okay. Okay. This is also some sports and racing tracks. Okay. Okay. I have to be careful for problems like this. Okay. So two motorists, Anil and Sunil, are practicing with two different sports cars, a Ferrari and a McLaren. Okay. On a circular racing track. Whenever I hear of the term McLaren, it reminds me of something interesting. Anyway. So yeah. So for the car. Okay. So anyway, I can't stop myself from telling you a story. So Elon Musk, okay, after he sold his first company, I think he went and bought one of the, again, McLaren is a sports car, and they have a very beautiful, beautiful showroom in downtown Palo Alto, where most of Silicon Valley is centered at. So Elon Musk ended up buying a McLaren with the money that he made from his first startup. And he actually got into an accident with it just a few days later because he was a car freak. And I always remember that incident. I don't know why. And his friend asked, do you have insurance for this? He says, I've not taken insurance. And he loses that. It's super expensive cars. These are almost, I think, $1 million cars. Anyway, I think I detract. Okay. So one of them has a Ferrari and other has a McLaren on a circular racing track. Okay. For the car racing tournament to be held next month. Both Anil and Sunil start from the same point on the circular track. Very good. Anil completes one round of the track in 1 minute. Very good. So Anil completes in one round in 1 minute. Okay. Sunil takes 2 minutes. Okay. Sunil takes 2 minutes to complete a round. While Anil maintains the speed for all the rounds, Sunil halves his speed after the completion of each round. Oh, so first round he completes in 2 minutes. Second round he'll complete in 4 minutes. Third round he'll complete in 8 minutes because he's halving the speed, right? Which means the duration will double, right? So the question here is how many times Anil and Sunil will meet between 6th and 9th round of Sunil. 6th and 9th round of Sunil, okay? 6th and 9th is excluded, okay? Only in 7th and 8th rounds, okay? Assume that the speed of Sunil remains steady throughout each round and changes only after the completion of the round. Okay, this is going to be time taking. Okay, so Sunil in his first round, right, he will do it in 2 minutes, 4 minutes, 8 minutes, then 16 minutes, then 32 minutes. Again, this is round 1, round 2, round 3, round 4, round 5. Round 6, he'll do it in 64 minutes. Round 7, he'll do it in 128 minutes. Round 8, he'll do it in 256 minutes. Round 9 in 512 minutes. And we are told we only have to focus on these 2 rounds. Right? We only have to focus on these 2 rounds. Right? Now the question says, how many times Anil and Sunil will meet between 6th and 9th round? Okay, excluding 6th and 9th round. So between these 2 rounds, okay, between these 2 rounds, because he'll take 128 minutes to clear this. Oh, they both are starting at the same time, right? So they both are starting at the same time, right? So which means, look at this, how many rounds, so how many minutes, so by the time he finishes 6 rounds, look at this, by the time this guy finishes 6 rounds, how many rounds did Anil finish? The sum of all of these, right? Right? If you look at it, because in 2 minutes, he finished 2 rounds. In 4 minutes, he finished 4 rounds. 8 minutes, he finished 8 rounds. Right? So by the time this guy gets into the 7th round, he's already, but the question here is, between the 7th and 8th round, in these 2 rounds, how many times will Anil and Sunil meet? Okay. So actually in the 7th round itself, Anil will meet him 127 times, 1 less than this. Okay. In the 8th round, he'll meet 1 less than this, 255 times. Because look at this, this guy is taking 128 minutes to finish the whole thing. That guy is finishing 128 rounds in that, which means how many meeting points will happen? 127 meeting points, right? Similarly, how many meeting points will happen here? 255 meeting points will happen, right? So if I sum up both of them, this will be the total number of rounds, number of times Anil will meet up Sunil while he's finishing his 7th and 8th round. So that will be 382, right? That will be 382, which is none of these actually, right? So which is actually none of this. Okay, sounds good. So let's go to the 14th question now. Again, these counterclockwise running, clockwise running, they can be tricky. Okay, so let's look at this question. ABC starts simultaneously from X to Y. So there are 2 points X and Y. ABC starts simultaneously. A reaches Y. Okay, so A reaches Y, turns back, and meets B at a distance of, so he turns back. When he turns back, he's meeting B here. Okay, where is B? Now B 11 kilometers away from, okay, he's meeting B 11 kilometers away from Y. So B is still moving in this direction. Okay, now B reaches Y. Okay, so this is the first point. So B reaches Y. So B reaches Y, turns back, and meets C at a distance of 9 kilometers, okay, from Y. Okay, if the ratio of speeds of A to C is 3:2, what is the distance between X and Y? Okay, okay, we have to use lots of variables here. Okay, okay, so let's assume the distance between both of them is D. Let me work it out. Okay, this is slightly tricky because we don't have the relationship between A and C directly. We have the relationship between A and B and B and C. So using these two relationships, one between A and B, the other between B and C, we have to work out the relationship between A to C. Because we're not given the relative speeds between A and B. We're only given the ratio of speeds between A and C, right? So we have to use the B as the intermediate value and somehow connect A and C. Okay, that's the tricky part here. So let's assume the distance here is D. Okay. Now in the first instance, right, what is the distance traveled by A? A travels D and then A travels 11. So A travels D plus 11 distance. Okay. What is the distance traveled by B? Distance traveled by B is D minus 11 in the first instance. Right? Simple. So, okay. So let's assume the speed of A is A and the speed of B is B. Okay. Because they both met here. I can write that the distance traveled by A divided by speed of A I'm writing it as A itself, okay, is equal to, because the time is the same, distance traveled by B by speed of B. Okay, this is one equation that I got using this. Remember, what am I given? I'm given the ratio between A and C. So I'm given A by C equals to 3/2. Here what I have is A by B. Okay, somehow I have to get B and C also so that I can get A by C. See, this is given to me, right? I have to get everything in these terms. So from this, what can I do? I can say, what is the distance traveled by B here? Distance traveled by B here is D plus 9. In the second situation, distance traveled by C is D minus 9. Just like this equation, I can write an equation for, I can also write an equation for this second step. I can write D plus 9 by B equals to D minus 9 by C. So I have two equations now. Okay. So if I write this as A by B, what will this be? I can write A by B as D plus 11 by D minus 11. From this equation, I can write B by C, right? I can write B by C as D plus 9 by D minus 9. What am I given? I'm given A by C. And what is A by C? A by C is nothing but A by B into B by C. I have A by B here, I have B by C here. If I just multiply both of them, look at this. If I multiply the RHS on both sides, this is equal to 3/2 because this is same as A by C. And this 3/2 is equal to D plus 11 multiplied by D plus 9 divided by D minus 11 multiplied by D minus 9. You'll get a quadratic equation now. Right? If you solve this, see, 3/2 is equal to this. You get a quadratic equation here, right? Or if you want to do it simply, just put in these values. Okay, you can solve the quadratic equation, you'll get an answer of 99 kilometers. Easier way is just put in this 99, what is the question here? What is the distance between A and B, right? Yeah, right, distance between A and B is nothing but D. If you solve for this, you'll get D equals to 99. It's a quadratic equation. Or simply speaking, just place this 9 here, everything will work out for you. Okay, so that's another way of thinking about it. Okay, sounds good. So this is the easy way of doing it. Okay. Okay, so one more question. So let's see what that question here is. Okay, so it says, okay, so this question says, one second. Okay, this question says, Raj, Shelly, sorry, Leo, Shelly, and Raj can complete a certain job in 10, 12, and 15 days respectively. Okay, so these time questions are actually fun because you have to always, I mean, again, let's read the question. Let's not jump to conclusions. They're assigned to work together to complete the job. All of them started the job together. Leo left 1 day before the completion day, and Raj left 2 days before the completion day. Okay. In how many days, okay, completion day of the job, in how many days the job gets completed? Okay, seems tricky. Okay, so since Leo can finish it in 10 days, Shelly in 12 days, and Raj in 15 days. Okay, so let's assume we want to have some number which is divisible by all three, right? So let's assume the total work. Okay, again, I can make this whole thing work without that also. To simplify the mathematics, let's assume the total work that we have, if it is divisible by all three numbers, right, that will make life simpler, the mathematics simpler for us. Okay, so let's assume the total work is LCM of 10, 12, and 15. Again, I could have taken it as an X, the mathematics will become complex, that's it, right? So what is the LCM of all of them? It is 60 units. So let's assume the total work is 60 units. Okay, this is an assumption. I could have taken X units also. Everything will work out even with X. But the mathematics is simpler if I take a number that is divisible by all. And why am I taking a number that is divisible by all? Now I can say the work done per day by Leo is 6 units. 6 units per day, right? And I get nice clean integers here because the 60 units total work is divisible by all three of them, right? Now Shelly does 5 units of work per day. Okay, so 5 units of work per day. This is total of 60 units and he can finish it in 10 days, right? So this will take per day, right? And Raj, since he finishes the total work in 15 days, he will finish 4 units per day. Okay, and the reason I took the LCM here is so as to get these integral numbers here. These are integers, making my life simpler, right? Now let's see what happens. Okay, so individually, okay, this is the rate at which they work. Okay, if they work together, how much work can they get done? If they work together, right, they can get 15 units of work per day if they work together, right? If they work together. Okay, so let's just assume, okay, that okay, Shelly can do 5 units, Raj can do, okay, who left? Leo left after 1 day before the completion, so we don't know what is the number of days of completion. Let's assume X is the total number of days that they worked. Okay, let's assume that's the total number of, that's the answer that we are looking for, right? Let's assume X is the total number of days that they worked, right? Which means Raj left 2 days before, which means for X minus 2 days, look at this, for X minus 2 days, everybody worked, all three of them were there, and all three of them together can get 15 units of work done. So in the X minus 2 days, this is the amount of work that they got done. Then, right, then Raj left. When Raj left, you have only Leo and Shelly. They both worked for 1 day together, which means how much work would have they got done in that 1 day? 11 units of work. And then finally, Leo also left and only Shelly was left. Shelly would have done 5 units of work on the last day. So this whole thing it says, right, this whole thing is equal to the total work done. What is the total work? 60 units, no? So they finished the whole work here, right? So this is 60 units. When I solve for this, I'll get X equals to 74 by 15. Right? Simple. Right? This is a simple equation. If I solve this, I'll get X equals to 74 by 15. And that's what I'm being asked here. Right? Very simple, nothing fancy here. Okay? I hope this is clear. Just give me a second. Just give me a second, folks. Okay, where are we? Okay. Okay, so let me stop it here. Okay, sounds good. So these questions are simpler. Again, as we discussed with you earlier, Just a second. Okay. So as we discussed with you earlier, we have uploaded all of the content for Aptitude. So please go through it at your own pace. But I strongly recommend and I strongly suggest and I request all of you, let's summer vacation for many folks, right? I understand some of you are working professionals who still have to go to work 9 to 5 or 9 to 8 or 9 to 7. I understand that, but let's speed it up so that we all can finish the content and get ample amount of time for practice, right? So 4 days, again, just reiterating what I told earlier. So next 4 days, let's finish all of calculus. Again, calculus for computer science is actually very simple. Okay, if you're to do calculus for mechanical engineering and electrical engineering, it's fun. The vector calculus, and it's a lot of fun. Anyway, so the syllabus for computer science itself is short, but it's important. You typically get a couple of questions sometimes from calculus, and it's super scoring. Okay, so next 4 days we'll finish calculus. We've also sent out the schedule for everyone, and instead of Saturday live session, we'll do it Sunday evening. We will not have a live session next Saturday. The reason we'll have it Sunday is because in these 4 days we'll finish everything in calculus. Sunday morning you'll get a subject test for a practice test for calculus. Sunday evening, let's solve the questions, pack up calculus, move on to other topics in engineering mathematics and discrete mathematics. Okay, again, only this Sunday, from next Sunday, we'll give you some time to revise. Okay, only this Sunday we are rushing through. Otherwise, from next week, we'll do it for 5-6 days and take a short break every weekend to revise. But now let's run. Okay, we want to finish maths as soon as possible, and looking forward to it. Again, calculus is something that I'm very fond of. Again, I'll show you some examples of calculus in computer science itself. Many people ask me, why did the GATE exam, why did the exam people who conduct GATE exam, right, professors at IITs, fairly knowledgeable people, why do they have calculus for computer science? I never used calculus. Actually, calculus is important for one of the most important areas of computer science, which is machine learning. Okay, so if you ever want to learn machine learning and artificial intelligence, calculus is something, especially differentiation, is something that you'll encounter every day. So concepts of differentiability, concepts of continuity are super important in designing the right machine learning algorithms, right? So I'll connect some of those dots to motivate you with some real world examples. I'll not be able to go too deep into machine learning and AI because I don't want to deviate from the GATE content, but I'll give you a couple of interesting examples on how calculus is useful for computer science student. Also, it's useful if you ever study image processing, if you study signal processing and things like that, which signal processing is something that the electronic students study in depth, but image processing is something that even computer science folks study a lot, right? So we'll cover calculus quickly and fast, and let's run now. Okay, so hope you all cooperate. Let's push it forward and let's get everything done as soon as possible. See you folks, and just FYI, the live is on Sunday evening, not Saturday evening. Okay, bye bye.